Now let's review the three trigonometry functions that we will be using in this course. To start off, I want to review our basic right triangle. Let's consider angle T. Now, when we are looking at describing the sides of the triangle, the side opposite of angle T is called the opposite. The side that's touching angle T, that is not the hypotenuse, the shorter side, is adjacent. And the longest side of the triangle and is always to the opposite of the right angle is the hypotenuse. Now let's use these terms to review our basic trigonometry functions. Sine of t is opposite over hypotenuse. Cosine is a ratio of the adjacent over the hypotenuse. Tangent is the ratio of opposite over adjacent. So trig functions are 100% simply ratios. You can remember these using the acronym SO, CA, TOA. You may have heard of those in high school. Now let's look at a triangle centered on the coordinate plane. When we center our triangle on the coordinate plane, we're going to assume our hypotenuse is 1. In this case, sine is going to be opposite over hypotenuse. Sine is simply going to be the y value. Cosine is the adjacent x over the hypotenuse, so cosine is simply going to be the x value. Tangent is opposite over adjacent, so it will be y over x. So let's work on a couple of problems here. Looking at this triangle, let's find the value of cosine of alpha. So cosine is adjacent over hypotenuse, so it's going to be 15 over 17, and that cannot be reduced. How about this triangle? We're going to find the cosine, sine, and tangent of alpha. This is called a 3-4-5 triangle. So opposite over hypotenuse will be 4/5. Cosine of alpha is adjacent over hypotenuse, so 3/5. Tangent of alpha is opposite over adjacent, so 4/3. Go ahead, pause the video, work on problem 3. As you return, we are going to be looking at finding the exact value for each trigonometry function. Now, before we do this, I want to show you a few special triangles. So our first triangle is going to be the isosceles right triangle. So both of those lengths are equal. Both of these angles are 45 degrees. Now for this triangle, we are going to assume that the hypotenuse is 1. So what would that make the length of these two sides? Well, we know that they're equal because this is an isosceles right triangle. We stated that at the beginning. Let's use Pythagorean theorem to figure out the length of these two sides. So we'll call them x. So x squared plus x squared equals 1 squared. 2x squared equals 1. X squared equals 1/2. Taking the square root of both sides, we get x, or one side of the triangle, is equal to 1 over the square root of 2. This is an improper way to write this fraction. I'm not going to be too picky about it in this class, but others may be a bit pickier than me. It's usually written as the square root of 2 over 2. Multiply top and bottom by the square root of 2. That will get rid of the radical on the bottom, that square root. So we only want square roots on top, not on the bottom. Like I said, I'm not too picky about it. I'd be okay with this, but you may see your calculator put it out as this, or you may see other instructors wishing you to write it that way. Let's look at another special triangle. Let's look at an equilateral triangle. Make it as equilateral as I can. So all of the sides are equal. All of the angles are 60 degrees. Now, what if we cut this triangle in half? Now, one side of this triangle is half of the longest side. So we said that these were all equal sides, right? So now, if we said that one side was length 1, this side is now length 1/2. What would that make the height of this triangle? This is a right angle. It's going straight down from the top, cutting it straight in half. It's going to be a perpendicular line, making that a right angle. So we can use the Pythagorean theorem to find the height of this triangle. So let's do that. So we have 1/2 squared plus x squared equals 1 squared. We have 1/4 plus x squared equals 1. Subtract 1/4 from both sides, we get x squared equals 3/4. Take the square root of both sides, and we get x equals square root of 3 over 2. So what? Right? We know the height of this triangle now. It's the square root of 3 over 2. Well, now this gives you more properties of another specific type of triangle called a 30, 60, 90 triangle. 30 degrees, 60 degrees, 90 degrees. So on a 30, 60, 90 triangle, if the hypotenuse is 1, the longer length is square root of 3 over 2. The shorter length is 1/2. This is going to help us figure out the exact value for each angle for the trigonometry functions. So let's look at 30 degrees. I'm not going to do this whole circle again. I don't want to kill too much of your time here, but I'm going to do at least the first couple of quadrants. So at 30 degrees, this angle right here is 30. This is 60. On the unit circle, when we talk about this line, we're always thinking it's length 1. So now what is the height of this triangle that we just created? It is 1/2, right? The side opposite 30 degrees is 1/2. Same thing up here. When we cut 60 degrees in half, this turned into 30 degrees. The opposite side is 1/2. What's the adjacent side? The longer of the two legs is square root of 3 over 2. So what does that mean? Well, when we're looking at our trig functions and we're looking at sine, 30 degrees, it's opposite over hypotenuse. Well, our hypotenuse is 1, so sine of 30 degrees is just 1/2. How about cosine? Cosine of 30 degrees is going to be adjacent over hypotenuse. Well, the adjacent is square root of 3 over 2. Hypotenuse is 1. Cosine of 30 is the square root of 3 over 2. How about tangent? Tangent is opposite over adjacent. So 1/2 divided by 3 halves. The halves are going to cancel out. It's going to be 1 over the square root of 3, or as pickier people like to do, square root of 3 over 3. let's look at 45 degrees. I'm going to change colors here. We'll go red. So now we have another triangle. We have hypotenuse of 1. Our side, we calculated over here, is the square root of 2, over 2. Or 1 over the square root of 2. I'm going to go with 1 over the square root of 2 just to make it less confusing. This side down here is 1 over the square root of 2. And again, we are looking at this 45 degree angle. So sine of 45. It's going to be opposite over hypotenuse, so 1 over the square root of 2. Cosine of 45 degrees is also going to give us 1 over the square root of 2. Tangent of 45 is going to give us 1 over the square root of 2 divided by 1 over the square root of 2. It is going to be 1. Now let's get rid of some of this stuff so that you can see the next few examples a bit better. So we're going to work on 60 degrees. I'm going to do some of the weirder ones with you, like 90 degrees and, get my eraser back. Oh, that worked nicely. I'm going to use that trick again. It lets me. Good enough. All right, let's look at 60 degrees. Go with green this time. 60 degrees, we're going to go all the way down here. Remember, hypotenuse is 1. The shorter side is 1/2. The longer side is the square root of 3 over 2. So what is sine? And again, this angle right here is our 60 degrees. Opposite over hypotenuse is going to be square root of 3 over 2. Cosine of 60 is going to be 1/2 over 1, or simply 1/2. Tangent of 60 is going to be opposite over adjacent. Square root of 3 over 2 divided by 1/2 is going to give us simply the square root of 3. All right, I'll get rid of that. We can look at 90 degrees. How is this even going to work? We have a 90-degree angle, but we can't make a triangle with it. So what are we going to do? All we have is this line that's of length 1. Well, look up here. Look up here and we see sine of t equals y over 1, cosine of t equals x over 1. This has proven true so far. So let's look here. Sine of 90 degrees is equal to y over 1. So what's our length y? How far is that? That's length 1, 1 over 1. So sine of 90 degrees is 1. How about cosine? Cosine is x over 1. Well, x is 0, so it's 0 over 1, which is 0. Tangent of 90? Opposite over adjacent. So what does that mean? Let's look up here again. Tangent was y over x. Y is 1, x is 0. Oh no, We're dividing by 0 again. We can't do that. We will destroy the universe. It is undefined. So there are times when tangent can be undefined. Let's look at another weird one. Let's look at 0. So, just as a reminder, sine equals y over hypotenuse, or 1 in this case. Cosine equals x over the hypotenuse. Tangent equals y over x. We'll note that the hypotenuse equals 1. So this length is 1. Sine is y over h. Hypotenuse is 1. Y, we aren't going up at all from the x-axis, so y is 0. So 0 over 1 is totally allowed, and it is 0. How about cosine of 0 degrees? Well, cosine is x over 1. X, we went over 1 because the hypotenuse is length 1. So cosine is 1 over 1, or 1. Tangent is y over x. Y is 0. X is 1. We get 0. Let's look at just a couple more. Maybe just one more. Let's look at 150 degrees. How do we create a triangle with 150 degrees? Well, we're going to go straight down to where the x-axis would be. Straight down here. Now, if we look at this, this is going to be similar to quadrant 2. So in quadrant 2, our x is negative. So that means that some of our functions are going to have negative values. What is this angle? Well, what's the difference between 50 degrees and 80 degrees? This is a 30-degree angle. This is a right angle. This is 1. If this is 30 degrees, the shortest side on 30 degrees on a 30, 60, 90 triangle is 1/2. And this side is square root of 3 over 2. So what is sine of 150? Well, look, first let's think about this. 1/2. It is going to be 1/2 going up, but because we're going to the left of the origin, this is going to be a negative 3/2. So sine is going to be opposite over adjacent, which is 1/2. So that's positive. How about cosine? Cosine is x over hypotenuse, so negative square root of 3 over 2. So cosine is negative here. Tangent of 150 degrees, we're going to have opposite over adjacent. 1/2 over negative 3/2 is negative 1 over the square root of 3. So you can continue to analyze these if you'd like to. Me or your instructor would be more than happy to work one-on-one with you if you wanted to continue working on this unit circle. So down here, we are going to use trigonometry to try to figure out the unknown side. We're given triangles. We're given a triangle that we know the exact values for, right? Because this is a 30, 60, 90 triangle. So we have to find the unknown sides. Well, on a 30, 60, 90 triangle, we know that the shortest side is 1/2 of the longest side. so the longer side has to be 14. The middle side is square root of 3 over 2 times the hypotenuse. So that'll be 7 times the square root of 3. Let's look at some application problems. So when we're talking about application problems, we have two angles that we're going to be looking at. The angle of depression means that looking straight on, the angle of depression is going to be moving down. There's also the angle of elevation, which means if you're standing on the ground looking up, the angle of elevation is going to go up. With these problems, it's going to be very helpful to sketch the situation and label it properly before going ahead and solving. So let's give this a whirl. To find the height of a tree of a person who walks to a point 30 feet from the base of the tree, she measures an angle of 57 degrees between a line of sight and the top of the tree and the ground. Find the height of the tree. Well, we know this angle, we know this length, we are looking for this. So we have our angle. This is the opposite of the angle. This is the adjacent of the angle. What trigonometry function can we use when we have the opposite and the adjacent? Tangent. So tangent of 57 is equal to opposite over adjacent. Now we simply solve for x. 30 times tangent of 57 equals x. So let's see what that is in our calculator. So 57 tangents times 30, we'll just round to the nearest tenth. We get 46.2. 46.2 feet. Take a moment and look at problem 7 and see if you can figure it out.